Hello everyone, I'm Jenil Patel. I'm going to demonstrate a project developed by my team, Three Musketeers, which is genetic algorithm. In this demo, we'll see implementation of natural evolution process as an algorithm. We'll see little triangular creatures whose goal is to hit a target. We'll call them ants, and they look like this. Every ant is an object who has its own DNA and behaves as individual organism. Let's move on to our website to understand the algorithm. This is our website. Our project is inspired by Darwin's theory of evolution. The strongest species survives. Our ants will try to hit the target, and if they fail, next generation will try to succeed. Our ants' DNA is a flow field. Our ants is moving with respect to their flow fields. Initially, we have a population of 500 ants, each with randomly initialized DNA. So in the first generation, the ants will move randomly to seek the target. After each generation, a portion of existing population is selected to breed a new generation. For the selection process, we have to construct a fitness function. In our case, we took fitness function as inverse of arrival time times distance from target power 6. So, if the arrival time of an ant is small, it will have higher fitness. And thus, if an ant has a good fitness score, it is more likely to be selected as a breeder. After the selection of best ants, the breeding processes happen. It is called crossover. In this process, two ants are randomly selected depending on their fitness scores. The child's DNA is generated from the parent's DNA as the picture shows, and this child will become part of the new generation. Now, in every evolution process, mutation is a very important factor. The mutation is used to maintain genetic diversity from one generation to the next. The new generation will have some kind of randomness in the DNA. If there is no mutation, the new generation will be completely same as the previous generation, and because of that, it won't be able to evolve itself when the environment changes. In our demo, if the population does not succeed till 10 generations, the mutation rate will increase a little so that the ants can find new ways to get to the target. You can see our project demo directly from our website, or you can download them through this link available. Now let's move on to the demo itself. This is our project demo. These are our ants and this is their target. Their task is to not only find and hit the target, but also do that in minimal time. In our life, if there comes any obstacle, we will find a solution to overcome it. Similarly here, if there comes an obstacle in their path, they will evolve and try to find new path to get to the target. So we can build an obstacle by dragging on screen like this. We can also delete it by right clicking on it. We can move this target by dragging it. Here we can see a purple circle on an ant. That ant is closest to the target. All ants have their own DNAs. As I said earlier, here the DNA is a flow field of two-dimensional vectors. If we press D on the keyboard, we can see the flow fields of the highlighted ant. Ant will try to follow the force vectors on this particular point of its flow field. We can hide it by pressing D again. In this panel, at the bottom, there are some details about the simulation. First is population size. Then there is generation number. and mutation rate. On the right, this is time in frames. In this demo, we have allotted 360 frames to a generation. This shows the minimum arrival of the last generation, and this shows the success rate of last generation. As you can see, they have already evolved in this environment, so let's change it a little bit. And observe. You can see that they have evolved again for this different environment. So download it and try it. Now at the end there are few scenarios as bonus clips. Thank you for watching.